So welcome back to Common Core Algebra 2. Today's lesson is going to be completing the square. Now this shouldn't be completely new to us because we've done completing the square in Algebra 1. So some of this might look familiar, but I figure that we should go through it because it is so important in the Algebra 2 curriculum. It's really kind of important to make sure we all remember how to do it. So completing the square and shifting parabolas. So what I'm talking about here in exercise 1, it says the function y equals x squared is shown already graphed. Okay, so this is the parent function, and this is the one that we compare all others to on a regular basis. So now we're taking a look at a new equation, which is right here. Y equals x squared minus 8x plus 18. So using the method of completing the square, write this equation in. Now they have it in this format right here, which is not my favorite way to write it, but it is in the y equals format. But when you're trying to find out what the vertex is, sometimes it's easier to write it a different way. So I'll show you what I'm talking about in just a minute when we get to that point. So we're going to start with, if you remember, our equation. So y equals x squared minus 8x, and I'm going to leave a little bit of gap, and I'm going to put the plus 18 all the way back here. Because in order to complete the square, in other words, what I want here is I want something squared and then plus something added onto it, the constant. So what we do is we take, to find how to find this second half here, we take half of negative 8, or half of 8, which is 4, and square it. So we're going to add 16 to this side, and that's basically going to complete the square here and here. But I want to remind you that if we're adding 16 and we're on the same side of the equal sign, we also have to subtract 16 to keep our equation unchanged. All right, so that's kind of important. So now what happens is this becomes x minus whatever that was half of, so it's x minus 4 squared. And then that's what this whole thing turned into, because I'm going to remind you just quickly, x minus 4 times x minus 4, which is the same thing as x minus 4 squared, don't write this down, is equal to x squared minus 8x plus 16, which is what we have right up here. All right, so that's what I mean by completing the square. All right, but now you have to take these two and add them together and get that plus 2 off the back. Now this is what this yellow up here is how this is written. But when they ask you to identify the vertex, which they're going to ask us to do down below, I'm going to show you it's easier if you write this with the y. So if you take this and bring this minus 2 over here, you get y minus 2 is equal to x minus 4 squared. And this is the way that we write typical conic sections, all right? But when we're not graphing them, when we are graphing them, it should be in the y equals format. But this makes it a little bit easier to identify the vertex. So if they want us to graph this, now, again, graphing this, we would go right to our calculator and graph it. So hold on, in a snap, I'm going to pull up the graph of this. So there we go. So that's what this particular parabola looks like. And again, no magic here, all about using the calculator. So B says, describe how the graph of y equals x squared would be shifted to produce the graph of y equals x squared minus 8x plus 18. Well, I mean, notice that I graphed it first because it's kind of easy to see now. I can see pretty easily if I think about geometry, I'm going to say y equals x squared is translated. Let's use some of our vocabulary from geometry. Is translated 4 units to the right and 2 units up. All right, so you don't have to use the whole translation notation, but they're asking you to explain or describe it, so we can very easily use words. C says sketch the graph, which I did already, all right, but it says using its vertex form. It will never tell you how to graph it because it can't tell you, it can't show, you can't prove how you graphed it. And what are the coordinates of the turning point, which is the vertex? And this is where this comes into play. So if you want to know what the turning point is, it's going to be x comma y. And what we do is we look at where the x is up here, and we take the opposite sign, 4, and we look at the y over here, and we take the opposite sign, and we say 2. So if you wrote it the way that they want you to write it, which is written this way right here, you have to remember that that positive 2 is really a negative 2 on the other side. So you have to make sure that you change the sign. Or in this case, you can say, well, I change the sign of this one, and I don't change the sign of this one. So like I said, finding a way, I always write it in this format, so that way I know I change both signs. And if I need to manipulate it back into y equals, it's easy enough to add 2 to both sides. Notice, I'm going to go back up here a second. Notice when I put both of these onto my graph, I labeled them because the rule of thumb is if you have more than one equation on a set of axes, you label them. If there's one, you don't need to. If there's more than one, you need to. All right, so because you don't want to lose stupid points for not labeling different graphs. Okay, going on to exercise 2. Using your calculator and the windows shown, sketch the graphs of the simple quadratics y equals x squared, y equals 3x squared, and y equals 1/2 x squared. The only thing I wanted to show you here is what happens when the coefficient gets larger and smaller. All right, so basically all I want you to recognize is if you looked at y equals x squared, that's our parent function. So y equals x squared might look something like this. Not exactly, but pretty good. Y equals x squared. All right, so y equals 3x squared is going to increase much faster. So y equals 3x squared is going to look something like this. So this is y equals 3x squared. And when you have a coefficient that's less than 1, then it's not going to increase and decrease quite as quickly. So it's going to look something like this one. That's all I wanted to make a point here. So this one is y equals 1/2 x squared. All right, so every quadratic of the form y equals ax squared has a turning point 0, 0. Okay, so pause that if you need to, and meet me at exercise 3. So if you look here, I kind of give you step-by-step instructions how to do this. All right, so it might help you if you're having difficulty. So place each of the following quadratic functions in vertex form by completing the square and identify the turning point. All right, so again, my advice here, please watch and then pause and write. So let's take a look at the first one here. So I have y equals, and I'm going to write this as x squared minus 4x. I'm going to minus 8, my apologies, 2 equal signs. Get rid of that. All right, so that was confusing for a minute. Have to change that in the book for next year. So then we take half of our middle term. Remember, it doesn't matter if it's positive or negative, because when you square it, it becomes positive. So I just kind of disregard the negative in front of the 4, and I just say half of 4 is 2, squared is positive 4. But I'm going to remind you, if you're adding 4 to this side, you have to make sure you minus 4 from this side, so we're not changing anything about our equation. We're just rewriting it. So y equals, and to find out what my square is, I simply take half of that middle term. So minus 2 squared minus 12. Again, if this is confusing you, you can rewrite it as y plus 12 is equal to x minus 2 squared, and my vertex is going to be positive 2, negative 12. Change both sides. Okay, pause and write. B, y equals x squared plus 10x, leave a little bit of space, minus 4. We're going to make sure that we are going to take half of that 10 and square it. So half of 10 is 5. Squared is positive 25. But I'm also going to minus 25, reminding yourselves that this is going to become my perfect square. So I get y equals x plus 5 squared minus 29. So if you're getting to the point and you don't need to write it that way, but again, feel free to. So it's y plus 29 is equal to x plus 5 quantity squared. So I know my vertex is going to be negative 5, negative 29. Or you can say to yourself, change this one, don't change this one. Okay, now that we've gotten you comfortable with completing the square, now we're going to change things up a little bit. So now we have a leading coefficient that's not equal to 1, which makes everything a little bit more confusing. So what we're going to do here is we're going to do y equals, and we're going to follow the same course that we did. But this time what we're going to do is we're going to factor out the 3. Let's change colors. All right, let's keep it the same color. So we have y equals, we're going to factor out, so we have a leading coefficient that's 1. So what I wanted to do here is divide each of these by 3. Notice I'm not going to do that with this one. So x squared plus 4x, and this is my perfect square, minus 2. So half of, I changed colors again, sorry about that. So plus 4x, take half of 4, take half of 4, which is 2, and square it. So now what I'm going to do here is I'm going to add 4 to both sides. So I'm going to add 4, add 4 here. You can add 4 to the y side if you want to, or I minus 4 off the back to keep it the same. But, oh, sugar plums, sorry about that. It's not 4, it's 3 times 4, because we're really adding 12. Sorry about that if I confused you. So we're adding 12, so we have to minus 12 on this side. So I get y is equal to 3 parentheses, x plus 2, take half of that 4 and square it. All right, take half of that 4, x plus 2 squared minus 14. If you need to, x plus 14 equals 3 times x plus 2. So I know my vertex is going to be negative 2, negative 14. Yes, the vertex does that. X still stays negative 2. You don't multiply. I'm sorry, there's a square here. You do not multiply the 3, distribute that, because remember, you have to distribute before you would be able to multiply through by that 3. And sometimes, like in this example here in D, sometimes the numbers don't turn out so nice, but I'm going to remind you, you have a calculator. Don't flip out by it. All right, if you start getting really crazy numbers, maybe you did something wrong, but these aren't half bad. And you can leave them as decimals, you can leave them as fractions, whatever you prefer. So in D, we get y equals, I'm gonna write the whole thing out first, because I think it's important that you follow a consistent pattern. So now you know that you have to factor out the 2. So when you factor out the 2, you get x squared plus 3x, and we're going to take half of that 3. Half of 3 is 3 halves. Square it is 9/4. Some people don't like that, so let's think decimals. Half of 3 is 1.5, and 1.5 squared is 2.25. So we're going to add, let's use a different color, we're going to add 2.25 here. Now remember, we still have that plus 1 here, but remember that we have to do 2 times 2.25 and minus that out. So you have to remember to minus 2 times 2.25, which is 4.5. 2 times 2, right? 2.25 plus 2.25, same thing as multiplying by 2. So now we just simplify this, and we get y is equal to 2 times x, take half of that, plus 1.5 squared, and positive 1 minus 4.5 is minus 3.5. So my equation turns out to be, my vertex, negative 1.5, comma, negative 3.5. All right, so that's the end of our lesson here. You're going to try the independent practice. If I've assigned it, get started on it. If you're having trouble because you don't have a calculator, all right, you can either go to Desmos and you can use the calculator there. You can use the calculator on your phone to help you a little bit, all right? But you should be able to do the majority of this without the use of a graphing calculator. All right. Some people were asking today in class if you can use your calculator to kind of back your way into it, and the answer is of course you can. And I would encourage you, wherever you can, try to spend just a moment and throw this into your calculator to make sure that these are the vertexes of your parabolas. It's always a good thing. All right, because again, it's a 2 or a 4-point question, and to be able to walk away from that knowing that you've gotten it perfectly right is so gratifying. All right, so until next time, always make good choices because I care about you. Take care. Bye.